Hey guys! Alright, today we're doing Chapter 8, Section 5 for FST, which is on infinite series. So we've talked about arithmetic series and geometric series, and remember that the only difference between a series and a sequence is the fact that we're adding all of our numbers up as we go, whereas in a sequence we just have all the terms. So if I'm talking about an infinite series, I'm talking about a series that doesn't end. It just continues and continues. Okay, so sometimes to get an idea about an infinite series, it's easier for me if I start by just looking at some partial sums, meaning I look at what's the sum of my first term, the sum of my first two terms, the sum of my first three terms. I don't know, let's look at them. And that'll kind of give me an idea about what is happening in the series. So for each of these problems, we're going to do a few different parts. So we're going to write the first 6 terms in the series, meaning the first 6 partial sums. We're going to find the first, we're just going to write the first 6 terms for part A, and then for part B we're going to find the first 6 partial sums. Then we're going to make a conjecture about whether it converges or diverges. Then we're going to write a formula if we can, and we're going to find the infinite sum if we can. So again, those parts D and E are just kind of, we might be able to do that depending on the series. So for the first one here, I've got the sum when n equals 1 to infinity, so the infinite sum of 1.5 to the n. So if I want to write my first 6 terms for part A, my first term would be when I plug in a 1. So if I plug in a 1, I get 1.5. If I plug in a 2, okay, I'll have 2, or 1.5 squared, which gives me 2.25. If I plug in a 3, I get 3.375. If I plug in a 4, I get 5.0625. If I plug in a 5, I get 7.59375. And finally, I get 11.39. Okay, so there's part A. For part B, I want to find my first 6 partial sums. So the sum of my first term is just 1.5. The sum of my first 2 terms, if I add those 2 numbers up, I get 3.75. The sum of my first 3 terms, if I add them all up, I get 7.125. And the sum of my first 4 terms gives me 12.1875. Sum of my first 5 terms and the sum of my first 6 terms okay. So now I've got my partial sums. So now I can do part C, and I can think about whether my infinite series converges or diverges. So looking at this problem, do you think that as I continue these partial sums here, I'm going to approach a finite number? Or do you think that it's just going to continue increasing up to infinity? Well, when I look at this, it doesn't look like it's slowing down. It doesn't look like it's going to approach a number. So I'm going to say that this probably diverges. I'm going to say that the limit to this is probably infinity. And because this is divergent, I can't do D or E. Okay, so we're going to move on to the next part here. So for this one, again, part A, I'm just trying to find my first 6 terms. So my first term would be when I plug in a 1. So this would be 0.5 to the 0, which is 1 times 12. So my first term is 12. And I get 6, 3, 3 halves, 3 fourths, and actually I'm going to write these as decimals. So this is 1.5, this is 0.75, and this is 0.375. Okay, so then part B, I want to find my first 6 partial sums. So my first partial sum is 12. My second partial sum is 18. My third partial sum, if I add all those together, I get 21. My fourth partial sum, I get 22.5. My fifth partial sum, I get 23.25. And my sixth partial sum, I get 23.625. Okay, so now looking at this problem, I need to think about, is this series converging or diverging? So does it look like it's just going to continue getting bigger and bigger and bigger without limit, or does it look like it's kind of slowing down and approaching a number? Well, to me, it looks like it's slowing down and approaching a number, because I noticed that 12 to 18 was a big jump, 18 to 21 was smaller, and then a smaller jump and a smaller jump, and now this one here is a really small jump. That means I'm getting closer and closer to a certain number. And I'm going to guess that it's convergent, and I'm going to guess that it converges to about 24. So this leads us to parts D and E, where whenever you have a geometric series that is converging, we can use a formula for that. Okay? And the formula we're going to use is on your formula sheet. It is S sub infinity, so the infinite sum is your G sub 1 over your 1 minus R. Okay, so in this case, my first term here is 12. My R value, I'm dividing by 2 every time, so this is 1 minus 1/2. Okay, so this is 12 divided by 1/2. I know that dividing by 1/2 is the same thing as multiplying by 2, so this will give me 24. So I was right, this series is going to be convergent, and it's going to converge to 24. Okay, so that's the answer to parts D and E. Okay, now I can move on to this next one. So this next one, I have an infinite sum of 1 over n factorial. So for my first term, okay, my first term is going to be 1 over 1 factorial, which would be 1 over 1. My second term is 1 over 2 factorial, which is 1 over 2. My third term is 1 over 3 factorial, which is 1 over 6. Okay, then I've got 1 over 24, got 1 over 120, and 1 over 720. Okay, then if I want to find my first 6 partial sums, I would do this in decimals if I were you, so I get 1, For my first partial sum, I get 1. For my second partial sum, I'll have 1 plus 1/2, which is 1.5. For my third partial sum, I've got 1.67. Okay. For my fourth partial sum, I get 1.7083. For my fifth partial sum, I've got 1.7167. And for my sixth partial sum, I get 1.7181. So, again, I need to think about, is this series going to converge or diverge? And it looks to me like I'm getting smaller and smaller every time, so this is probably going to be convergent. So now I want to estimate what I think this series converges to. Well, a good estimate would probably honestly be 1.72. So I'm going to say it converges to 1.72. And that might seem kind of small, but you'll notice how small I'm increasing. And just think about how large you can exponentially increase. Well, I'm basically increasing at a very, very small exponential rate. Okay, so it's just going to increase by a smaller and smaller and smaller amount exponentially each time. So 1.72 is probably a good estimate about where this series will converge. And I can't do parts D and E because this is not geometric, therefore I can't actually plug this into the formula. Alright, last one. I'm going to start with A, so I want to come up with my first 6 terms. So this is 1 over I squared, and I'm going from 1 to infinity. So for my first term, I'll have 1 over 1 squared, which is 1. For my second term, I'll have 1 over 2 squared, which is 1 over 4. And then I'll have 1 over 3 squared, which is 1 over 9, 1 over 16, 1 over 25, 1 over 36. Okay, then I can find my first 6 partial sums. So S of 1 is 1, S of 2 is 1.25, S of 3 is 1.361, S of 4 is 1.4236, S of 5 is 1.4636, and S of 6 is 1.4914. So again, I need to consider, is this converging or diverging? I'm going to say it converges. And the number that I think it's converging to, I'm going to say 1.5. It sure looks like it's getting closer and closer to 1.5. All right, that is everything for section 5.